Jai Hind, I am Dr. Shravan Kumar Garg, and today we are going to discuss Introduction to Computer Systems. Actually, before start learning any programming language like C language, we must know the basic functioning of any computer system. That's why I have chosen this topic today, so that we can understand how computer system works. There are many things that a computer do, and so we start with the first topic. First topic I have chosen is basic operations performed by computer system. There are actually 5 basic operations that are performed by any computer system, and these operations are input, processing, output, store and controlling. So the first operation is inputting. What is inputting? Inputting is the process of entering data and instructions into the computer system. Means the process through which we can input our data and instructions. Actually, data is the value on which some operations has to be performed, and that operation can only be performed with the help of instructions. So both the data and instructions are to be input into the computer system, so that computer can store that data and instruction into it. There are many devices installed inside the computer. For example, hard disk, pen drive and other secondary memory devices into which we can store our data inside the computer. So the second operation that any computer perform is storing the data. So saving data and instructions to make them readily available for initial or additional processing. Once data is stored inside the computer, it can be used for further processing, so that the useful result can be provided to the computer, to the user. Third operation that is performed by any computer is processing. Processing means perform some operations on the data that is input by the user into the computer system, and processing involves arithmetic operations or logical operations. Arithmetic operations like addition, subtraction, multiplication and division, and logical operations like less than, greater than, less than equal to, greater than equal to or not equal to. These are some operations that are performed by computer system. Third operation that is performed by computer system is outputting. Outputting means after receiving the input and processing that input, convert it into the useful information so that it can be useful for the user. The information that is useful to the user is called outputting. So the outputting is the process of producing useful information or results for the user. For example, printed reports or visual display. These are the examples of outputting. And final operation that is performed by computer system is controlling. Controlling means to control all the above 4 operations in a sequence or in a manner, so that correct output is provided to the user. So fifth operation is controlling. So these are the 5 operations that are performed by any computer system. So now we will understand the block diagram of computer. Through block diagram of computer, we can understood what are the parts that are available inside the computer and what is the actual working of that part. So we can divide our computer system into 4 units. First unit is input unit, second is output unit, third is storage unit, and fourth one is central processing unit. In short form, we can call it CPU. So input unit is used to take data and instructions from the user. Output unit is used to produce results to the user. Storage unit is used to store the data, and central processing unit is used to process the data, as their name suggests. Now we will study all these units in detail. So various examples of input unit are available. We must know what are the various devices that are available in the market to input the data inside the computer. There are many devices available. For example, keyboard. Through keyboard, we can input text data inside the computer. Like in human being, there are various modes through which we acquire some data. Like voice can be acquired by human being through their ears. Images and videos can be acquired by human being through their eyes. In the same way, there are many input devices available in the market for various types of inputs. So for text type of inputs, we can use keyboard. To point something on the computer, we can use mouse. So mouse is another input device. Next one is mic. Through mic, we can input voice inside the computer. Next one is camera. Through camera, we can input video inside the computer, and so on. There are many input devices available in the market. Some of them are like joystick is also there, through which we can control the functioning of the computer. There are many devices available. Now we must know what are the various output devices that are available in the market. Many output devices are screen, or we can say monitor. This device is used to display the output on the screen. The output that is available using these devices is called soft output, or we can say soft copy. So the output provided by screen is soft in nature. Soft means as soon as the power is off, the output that is visible to the user will be deleted. Next type of output devices is printer. Through printer we get hard copy. As we get the output in the form of printed paper, so that output is called hard copy. And there are many other output devices also, some of like speaker, through which we can get voice as an output, and etc. Before moving further, we must know the actual working of these devices, how these devices work. Means input devices and output devices. Actually, input devices accept data from the user in the form which is readable to machine. Input devices receive data from the user. Just a minute. So input devices receives input from the user, and that input is in the format which is readable to machine. So first step is it accepts instructions and data from outside world. Second one is convert that input and data into machine readable form, as that input has to be moved inside the machine, that is computer system. So before inputting that data and information to the machine, it has to be converted into the machine readable form. So second step is it converts these instructions and data in computer readable form. And third one is it supplies the converted instructions and data to the computer system for further processing. So these are the three steps that are performed by any input unit, whether it is keyboard or mouse or any input device. All the input devices perform these three functions. First one is accept the input, second one is convert that input into machine readable form, and third one is supplies that input inside the computer system so that computer system can perform some processing on that input. In the same way, output unit also performs three functions. Obviously those three functions will be in reversed form. For example, the first function would be it receives output from the machine. Second one is it converts that output into the user, means human readable form, so that human can understood. And third one is it supplies that converted information to the outside world or to the user. So these three steps are written over here. We can see first one is it accepts the results produced by the computer which are in coded form and hence cannot be easily understood by the user. Means first step is it accepts the output from the machine. I am talking about output unit. All the output unit perform these three functions. First one is accept the output from the machine. Second one is converts that output into machine readable, human readable form. And third one is supplies the output to the user, or we can say outside world. So these are the functions performed by output unit. Now we go back to our diagram. Now we understood how input unit works and how output unit works. Now we will learn what is storage unit. Actually, storage unit is like a human mind. It stores information. storage unit in computer divided into two parts. First part is called primary storage and second part is called secondary storage. Actually, primary storage, there is a difference between primary storage and secondary storage. We must know the difference. Primary storage is volatile. Volatile means as soon as the power is on, information inside it is available, and as soon as we switch off our computer, information that is stored inside primary storage get washed out, means get erased. But the secondary storage is non-volatile, means when we store some information into the secondary storage, it is still available even after the power is off. So there are many examples. There are many examples of secondary storage. As we know, hard disk is an example of secondary storage. Other example may be a pen drive, etc. And the example of primary storage is RAM. Full form of RAM is random access memory. It is the same thing like that we have seen in our mobile phones, 4 GB RAM or 8 GB RAM. So that RAM is actually a primary storage, and hard disk, pen drive, etc. these are called secondary storage. Now we must we will discuss the difference between primary memory and secondary memory in detail after some time. But before that, I would like to tell you, or you should know, that when we input something from using input unit, where that input goes to, whether it goes to secondary unit or it goes to primary unit. Actually, the input that is supplied by the user directly goes to primary unit. That we supply, when we supply some input to the computer system, it goes directly to the primary storage, and the output that we receive on our screen or on our printer, that is also from the primary storage. Means the input that we give to the computer, it goes to the primary storage, that is RAM, and the output that we receive from the computer is also from the RAM. Then what is the use of secondary storage? Actually, when user inputs some data to the computer system and user wants to save that information or data so that user can use it as and when required, means later on, after some days or after some hours or after some time, suppose user want to use that data for that purpose. If user want to save that data permanently inside the computer system, so the user can save that data from primary storage to secondary storage. And when we want to use that stored data from our computer system, we can also retrieve that data from secondary to primary. Let me give you an example. Suppose there are many songs stored in my computer system. All those songs, where these songs are stored, all those songs will be stored in secondary storage. Suppose there are 100 songs. So to listen any song, we need a software that is called media player. That media player is also stored in secondary storage. Suppose now I want to listen any one song out of those 100 songs. For that I need to retrieve that song from secondary storage to primary storage. So along with that song, the software that will be used to run this song is also loaded from secondary storage to primary storage. And as soon as both song and that media player will be loaded into the primary storage, we can hear the sound of the song from the speaker. So in this case, that song is called data, and that media player will work as a instruction. Media player, because both these things are required to run any song. Suppose you have only song in your computer system or in your mobile and you don't have media player, you won't be able to run that song in any case. So both these things are required. So song is a data. Suppose you have only media player in your computer system, you don't have any song, you won't be able to listen any song from your computer system or from your mobile. So to listen any song, we require both things, song as well as media player. So in this case, song is a data and media player provides the instruction to play that song. Now we will see the differences between primary storage and secondary storage. Some of the differences I have already told earlier, like primary storage is a volatile memory and secondary storage is a non-volatile memory. Again, I would like to tell you, volatile means as soon as the power is off, the information stored in that memory will be lost. But in non-volatile memory, after the power is lost, information stored in it will not be lost. And second difference is the example of primary and storage, primary and secondary. Example of primary storage is RAM and example of secondary storage is hard disk, or we can say pen drive. Now we will look into the more differences between primary and secondary storage. So before looking into the differences, first of all we must know what are the various functions of storage unit. So first one is data and instructions required for processing. It stores, means storage unit stores all the data and functions that are required for any type of processing. So from where that data and instruction will be received? Obviously from input device. So those data and instructions that are required for processing are received through input devices. Second one is intermediate results of processing. Suppose we are performing some calculation inside the computer and that calculations means produces some intermediate results. Those intermediate results are also stored inside the storage unit. And third one is final result of processing. So before the final result is produced to the output unit, means before the final result is provided to the user, that final result is also stored inside the storage unit. So there are three types of data that are stored, data or we can say instructions that are stored inside the storage unit. First one is the data and instruction that is provided by the user to the computer system. Second one is intermediate results, and third one is final result before it is provided to the user with the help of output devices. I would also like to give you an example of intermediate results. Suppose you want computer to add numbers from 1 to 5. We know that in this case 1, 2, 3, 4 and 5, this is the data that the user is provided to the computer. What operation has to be performed? Obviously I have just said that we want to sum numbers from 1 to 5, so plus is the instructions. So that data and instruction is inputted to the computer system. Now computer will start adding these numbers. 1 plus 2, 3. 3, in this case 3 is the intermediate result. That 3 will be added to next number, which is also 3. 3 plus 3, 6. 6 in this case is intermediate result. 6 will be added to 4. Let me show you. Suppose you want to add 1 plus 2 plus 3 plus 4 plus 5 using computer system. Using computer system. In this case 1 plus 2 plus 3, 1, 2, 3, 4 and 5 is data. And the operation that has to be performed on these data is instruction. So this is inputted to the computer system. So this is the initial data. Now computer will start adding these numbers 2 at a time. 1 plus 2, 3 plus 3 plus 4 plus 5. So in this case, this 3 is intermediate result. Now 3 plus 3 6 plus 4 plus 5. 6 is also intermediate result. 6 plus 4 10 plus 5. 10 is also intermediate result. 10 plus 5 is equal to 15. In this case 15 will be the final result. So storage unit is used to store three types of data. First one is initial data, that is input by the user. Second one is intermediate result, and third one is final result. Now we will look the differences between primary and secondary storage. So these are the features of primary storage. First one is it is used to hold running program and instructions. I just gave you an example that suppose you want to run a song into your computer system, so you have to load that song into the primary storage, that is RAM. Just a minute. RAM. So the running program's data and instruction is stored inside the RAM, that is primary storage. Second one is it is used to hold data, intermediate results and final results of ongoing process or jobs. Third one is it is fast in operation because it is small. Because it is small, hence it is fast in operation. What do you mean by small? Small means its storage capacity is less as compared to secondary storage. Its capacity is like 4 GB or 8 GB, 16 GB. So these are the most frequently used storage capacity of RAMs nowadays. So it is fast because its capacity is small. That's why it is fast in operation. Third one is expensive. Although its capacity is small, but the architecture that is used to build this RAM is costly. That's why it is expensive. And last one is volatile. It is volatile. Volatile means all the data will be lost as soon as the power is off inside the computer. Now we will look into the features of secondary storage. Obviously, like it's fast in operation, the feature of secondary storage would be that it is slow in operation as compared to RAM. It is small capacity, storage capacity of secondary storage is large, very large. Now have a look. Secondary storage. It is used to store program and instructions. We can store any program or instructions, means data and instructions inside the secondary storage. Similarly, in the way as we store data and instruction inside the primary memory. The only difference is that it retains data even without power. Means once the data is stored inside the secondary storage, it remains in it, whether there is a power or not. When user want to delete that data, means erase that data, user has to do that himself without the will of user, if user do not want to delete that data, no one can delete that data that is stored inside the secondary storage. And I have already told that example of secondary storage is hard disk in case of computer, or we can say internal memory in case of mobile device. We usually use this word memory, device memory in the case of mobile devices. So its capacity is large, but due to its architecture, means the architecture through which secondary storage is created, is built, it is cheaper as compared to primary storage, and it is available in a storage capacity like 500 GB, 1 TB, etc. Now you can compare the storage capacity of any storage, any primary and secondary storage. As RAMs are available in like in the size of like 4 GB, 8 GB, and you can compare the size of secondary storage. It's in 500 GB or 1 TB or 2 TB. Although size of the secondary storage is more, but due to their architecture, its cost is cheaper than primary storage. Because its capacity is large, hence it is slower than primary storage. It is used to hold data and information of stored jobs. So means first two functions are the same, but the first two features are the same, but the main difference between primary and secondary storage is their means speed, their storage capacity, their they are volatile or not, and their cost. So I would like to conclude that RAM is means expensive, means primary storage is expensive, secondary storage is cheap. Primary storage is small in size in terms of storage capacity, but secondary storage are available in large capacity. Third one is primary storage is volatile in nature, but secondary storage is non-volatile in nature. And the last one is primary storage is faster in speed, faster in execution speed, and secondary storage is slower in execution speed. Again we move to the diagram. Now we have already studied about input unit, output unit, storage unit, and how storage unit works. Now we will move to the last block of this diagram, and that is central processing unit. Central processing unit is also divided into two parts. First one is control unit and second one is arithmetic logic unit. First of all, we will discuss arithmetic logic unit. Short form of arithmetic logic unit is ALU. As we can see, as we can see here, arithmetic logic unit is used to perform all the operations that are required to perform some useful result. So arithmetic logic unit perform all the processing of computer system. So various operations performed by computer system, as we have already discussed earlier, are arithmetic operations and logical operations. There are only two operations that we perform. We human beings also perform these two operations. We do not require to perform any other operation in terms of processing. So arithmetic logic unit, that is ALU, also perform these operations, and these operations are arithmetic operations. Second one is logical operations. There are basically four arithmetic operations. First one is addition, second one is subtraction, third one is multiplication, and fourth one is division. Similarly, there are six operations under logical operations category. First one is to compare to less than, to compare less than or equal to compare greater than, to compare greater than or equal to compare whether two things are equal, and to compare whether two things are not equal. So these are the operations that are performed by ALU. And the last part of this block diagram is control unit. So control unit, what control unit is? Control unit is used to control all the operations of computer system. Means when input unit can input the data inside the computer, where that data is stored inside the computer, when will be the output will be available to the user, what operation will be performed on the input data. Means to control all the operations, right, beginning from the input and to the final stage, that is output. All the operations are controlled by control unit. We can say it is the nervous system of computer system. Like what nervous system does in human body, in the same way control unit perform its function inside the computer system. So by combining these two units, that is ALU and CU, the one big unit will be called central processing unit. So we can say, what is CPU? CPU is a brain of the computer system because it performs all the arithmetic and logic operations and it controls all the functioning of computer system. Hence, by combining these two units, one bigger unit will be created and that unit is called CPU. It is responsible for controlling the operations. Obviously, this is done by control unit. Okay, I would like to tell you one more thing, that there is one more part of CPU. So, here in this diagram, if we look at this block, that is CPU, two parts are mentioned. First part is control unit and second part is arithmetic logic unit. Actually, there is one more part there. Just a minute. Actually, one more part is there, and that part is called registers. So we can say that CPU is divided into three parts rather than two parts. First part is control unit, we all know what is the function of control unit. Second part is ALU, we all know what is the function of ALU. Now I will tell you what are registers. Actually, registers are small memory inside the CPU, and that memory is used to store intermediate result. Now many of you may get confused. Earlier I told you that intermediate results, whether it is intermediate result, whether it is final result, or whether it is initial value that is inputted to the computer, all the three types of data is stored inside storage unit. But now I am saying that registers is also a small memory that is inside the CPU, and this small memory is used to store intermediate result. Actually, by using registers, the processing speed of our computer increases many times. That's why to store only intermediate results, this small memory which is called register is provided inside the CPU. For example, suppose we want to add 5 numbers, 1 plus 2 plus 3 plus 4 plus 5. These numbers are inputted by the user to the primary storage. These numbers 1, 2, 3, 4 and 5, and the operation that has to be performed on these numbers is plus. That is, we require the sum of these 5 numbers. Now, which part of the computer system will perform the operation of addition? Obviously, we know ALU will perform the operation of addition. So, out of these 5 numbers, 2 numbers will be provided to the 1 and 2. These 2 numbers will be provided to the ALU, and control unit will tell ALU that it has to perform addition operation on these 2 numbers. Now, ALU will perform addition and the output of 1 and 2 will be 3. Where this 3 will be stored if registers are not provided inside the CPU. Obviously, this value 3 will be stored back into the primary storage. But if registers are provided inside the CPU, computer can store that 3 inside the register. So by using that internal memory which is inside the CPU, the speed of computer can be increased. That's the purpose. Nowadays registers are provided inside the CPU. Now we will move to the last topic of our today's class, and that is the system concept. As I have told in the beginning that today we are going to study computer system. There was a word system. We must know what do you mean by system. We must know what is the meaning of system. That's why we should understand its concept. So whether any system is available in the world, every system has three characteristics. Number one, a system has more than one element, means it must consist of more than one element. Like in our case, in case of computer system, there are four elements majorly. First one is input unit, second one is output unit, third one is storage unit, and fourth one is central processing units. Second characteristic is all elements of a system are logically related. Like in our case, input unit is connected to the storage unit is connected to the output unit and central processing unit, and all the operations that are performed inside the computer system is controlled by control unit. So all the elements of system must be logically related. And the third characteristic of any system is all elements of a system are controlled in a manner to achieve the system goal. Who is controlling our system? Our computer system. As I told earlier, control unit is controlling all the operations that are performing inside the computer system, whether it is input, whether it is output, or whether it is processing. All the operations are controlled by control unit. Hence, we can say that our computer is a computer system. So, now I am concluding. A computer is a system as it comprises of integrated components, that is input unit, output unit, storage unit and CPU, that work together to perform the steps called for in the execution of program. Hence, we can say our computer is a system. Okay, thank you.